Hey y'all, welcome back. Tonight's homework is all about exponent properties, and we're going to use those exponent properties to simplify all these expressions. So for problem 1, we've got 16 squared times 16 cubed. Whenever you're multiplying two powers that have the same base, you simply add the exponents, so 2 plus 3, which would be 5, and you could use a calculator to evaluate this, but I'm just going to leave it as 16 to the 5th power. Again, if you want to know exactly what it equals, you could throw it in the calculator, but right now I just want to focus on the properties themselves. Number 2 says x cubed times x to the 5th. So whenever we're multiplying, once again, two powers with the same base, we're going to add those exponents together. And 3 plus 5 is 8, so our answer here will be x to the 8th power. Number 3, we've got these sort of pointless parentheses out here. We can drop those safely since there's really no point in having those. Otherwise, we have y to the 4th times y to the 8th, which will be the same thing as y to the 4 plus 8. And 4 plus 8 is 12, so our answer here is y to the 12th. Not really sure what's going on with those outside parentheses. Number 4, now we're getting into division here. So like with multiplication, the rule is whenever you're multiplying two powers with the same base, you add the exponents. For division, whenever you divide two powers with the same base, you subtract the exponents. So here we've got 6 to the 4th over just 6, which is equivalent to 6 to the 1st. So 4 minus 1 would be our new exponent. So we have 6 to the power of 4 minus 1. 4 minus 1 is 3, so we do get 6 cubed. Number 5, same kind of problem here. We are dividing, so we're going to subtract our exponents. So this will be a to the power of 6 minus 4, and 6 minus 4 is 2. We'll get a squared. Number 6, I'm going to start by multiplying these first. So we're actually going to end up using two properties. First, the product property, so we'll add the exponents, and then we'll use the division property to and subtract the exponents. So first I'll multiply these together. That gives me t to the 5th times t cubed all over t squared times t. So we don't need that first equal there because there already is one. But here we're going to add these exponents together. So t to the 5th times t to the 3rd is going to be t to the 8th. And then whenever you have a lonely t, that's equivalent to t to the 1st power. So 2 plus 1 is going to be 3. So we have t cubed. And now we're going to subtract our exponents. Anytime you divide and you have the same power, you can subtract the exponents. So 8 minus 3 is going to be 5. And so our answer is t to the 5th. For number 7, we've got 7 to the 0th power. Anything to the 0th power is 1. So this is just going to equal 1. Number 8. We've got x to the 8 over x to the 8. X to the 8 minus 8 is going to be x to the 0, which, just like the previous problem, is going to equal 1. Number 9, we've got this extra times 2 out here. Can't really do anything with that. But what we can do is, I'm going to actually put that 2 out in the front. Say times g to the 6th plus negative 6. Okay, so whenever you're adding a negative, that would be equivalent to just subtracting. So I'm doing 6 plus negative 6, which is the same thing as 6 minus 6. Now 6 minus 6 is 0, so we have 2 times g to the 0th, and anything to the 0th power is 1, so this would be the same thing as 2 times 1, which would just be 2. Number 10, we've got 6 to the 4th divided by 6 to the 7th. So that would be 6 to the power of 4 minus 7. 4 minus 7 is negative 3. So we have 6 to the negative 3rd power. And going back to the directions here, it says leave no negative exponents in your answer. So we do need to write this using a positive exponent. And that's pretty conventional that in order for an expression to be simplified, you don't want any negative exponents. So we can write this as 1 over 6 to the positive 3. So that's how you deal with those negative exponents. Just move that term to the other side of the fraction and negate the exponent. For number 11, we're going to have negative 4 to the power of 3 minus 7, which is going to be negative 4. So we have negative 4 to the power of, well, negative 4. And so if we want to rewrite this using a positive exponent, we're going to have 1 over negative 4 to the positive 4th power. And we can just leave it like that. You could use a calculator to calculate this, by the way, but I'm just trying to focus on the exponent rules here. Number 12, f to the 5 over f to the 7 is going to be f to the 5 minus 7. 5 minus 7 is negative 2, so we get f to the power of negative 2. Now, just like with the last one, we can't leave it like that, unfortunately. So we're going to rewrite this as 1 over f to the positive 2. So 1 over f squared. For number 13, we have a negative exponent, so we want to rewrite this with a positive exponent. So 1 over 6 cubed. That's pretty much going to be our answer. You might be able to do x cubed in your head. It'll be 216, but I'm okay with you just leaving it like this. Number 14, same kind of problem here. We're just rewriting this with a positive exponent, so it's just going to be 1 over g to the positive 8th power. Number 15, we're going to add those exponents because we are multiplying two powers with the same base. So this will be 3 to the power of 4 plus negative 2. We had another problem like this. Which one was it? Number 9. Whenever you're adding a negative, that's the same thing as subtracting. So I can just write this as 4 minus 2. 4 minus 2 is 2. And while I am okay with you just leaving it as 3 squared, this one is easy enough to do in your head that I think even without a calculator, you should be able to come up with just 9. But if we're doing something like, 6 cubed, okay, maybe I ask you to do that. But if I ever ask, I'm never going to ask you to do something like 16 to the 5th. So just in general, it's okay to leave it as a power. But if you can do this in your head, then go ahead and simplify it a little bit further. All right, 16 through 18, we've got these huge fractions. And so what I think I'll do here is just simplify first the coefficients. So I'm basically going to take this one step at a time. So I'm going to compare these. I'm going to simplify this fraction. Then I'll look at my w's and my x's and so forth and so forth. So here we've got 7/14. This is going to reduce to 1/2. And then I've got w to the 4 minus 1. Okay, because 4 and then 1. Times x to the negative 2 minus 3. So I'm just subtracting the exponents. I have to give myself a little bit more room here. Times y to the 7 minus 7. Times z to the 1 minus 5. All right, so we've got 4 minus 1 is 3. Negative 2 minus 3 is going to be negative 5. 7 minus 7 is 0. And then 1 minus 5 is negative 4. So I'm going to clean this up just a little bit. And now I'm going to go back to my big fraction here and put all the positive exponents on the top, and any negative exponents, I'm going to change them to be positive exponents and put them on the bottom. So w cubed is going to go up here. X to the negative 5th, I'm going to rewrite as x to the positive 5th and put it in the denominator. Y to the 0 is just 1, so we're just multiplying by 1 here. We don't need that. And then we have the z to the negative 4th, so I'm going to write z to the 4th down in the denominator. So here would be your answer for number 16. For number 17, we'll work this out similarly. 36 divided by 12 is just 3, so I can simplify that. And I have times a to the first minus negative 4. So subtracting a negative 4 would be the same thing as adding 4. So I have 1 plus 4 there. Then I have b to the 5th minus minus 1. And then for the c's, I've got c to the first minus negative 3. Again, whenever you have minus a negative, it's going to change to plus. So here I've got 3 times a to the 1 plus 4 is 5th. 5 minus 1 is 4. 1 plus 3 is 4. And we actually don't get any negative exponents on this, so we can just leave it as 3 times a to the 5th times b to the 4th times c to the 4th. For number 18, I'm going to set this up very similarly. We're And all these basically out the same way here. Negative 8 divided by negative 4 is just going to be 2. And then I have times x to the negative 9th minus 1 times y to the 5th minus 1 times z to the negative 2nd minus 2. So we get 2 times x to the negative 10th times y to the 4th times z to the negative 4th power. Now I do have some negative exponents in there, so I will need to rewrite this. 2 over 1 is the same as 2. I just need a fraction here. Make sure the 2 goes on top. Then we have x to the negative 10th, which is going to go on the bottom, but with a positive exponent. Then we have times y to the 4th, that's going to end up in the numerator, and then z to the negative 4th is going to end up in the denominator with an exponent of positive 4. All right, let's take a look at number 19, which is a multiple choice item. So here on number 19, I'm going to start by reducing this fraction, 14 over 8, which will reduce to 7/4. Then I'm going to look at my a's, and I'm going to subtract their exponents. So a to the 4th divided by a to the negative 2nd power. It's going to be the same thing as a to the 4th minus negative 2. Now minus negative 2 is the same thing as 4 plus 2, so I'll leave it like that. Then we've got b to the power of 6 divided by b cubed, so that'll be b to the power of 6 minus 3. Finally, we've got c. So we've got c to the power of negative 10 minus negative 5. So minus negative 5 is going to be the same thing as plus 5. And now we can start to simplify all these exponents. So 4 plus 2 is going to be 6. 6 minus 3 will be 3. And negative 10 plus 5 will be negative 5. Now to clean this all back up and write it how you see the answer choices, we want to write this as one big fraction. So all the powers that have positive exponents are going to go in the numerator, and then all the ones with negative exponents we'll put in the denominator with a positive exponent. So we'll put a to the 6th up here in the numerator times b cubed, and then we'll put c to the 5th in the denominator. So here's our answer. Let's go ahead and look, and yeah, we've got that in choice B. Number 20 says a circle has a radius of 6 times x to the 9th times y to the 5th centimeters. The area of a circle can be found by using this little area formula, pi r squared. What is the area of the circle in square centimeters? So really the only thing we need to do is substitute this 6x to the 9th, y to the 5th in for the radius. So right here, 6 times x to the 9th times y to the 5th. When we square all that, we're going to square each factor individually. So 6 squared will be 36. X to the 9th squared will be x to the 18th, because we multiply powers when we raise a power to a power. And then we have times y to the 10th. You can move around these terms as you'd like. Multiplication is commutative, so you're allowed to do that. So we get 36 pi times x to the 18th times y to the 10th. And we can see that our answer is choice C. All right, let's look at number 21. It says a rectangular prism has a width of x inches, a length of x squared y inches, and a height of y squared, which expression represents the volume in cubic inches of this rectangular prism. So the volume of the rectangular prism is going to be the width times the length times the height. And so I'm going to replace all of those variables with the expression we're using to represent each one. The width is just x, the length is x squared times y, and the height is y squared. Now we don't really need to regroup anything because the x's and y's are all together here. So here we have x times x times x times y times y times y. Whenever you have a variable squared, that means you're multiplying it by itself. And so now that we regroup, we can see that we have 3x's, or x to the third power, times 3y's, or y cubed. Our answer is, let's see, do we actually have this one? Did I miss something? Oh no, it's right here, D. Number 22 says which expression is equivalent to this one, and this is really just a matter of knowing your exponent properties. So whenever you multiply two powers with the same base, you add the exponents, so that would be z to the power of a plus b. And then, so that would be what you have up here in the numerator, and then to combine it with the one in the denominator, you're going to subtract those exponents. So minus c, that's really all there is to it on this one. You don't even really need the parentheses there. I guess they're just there to kind of help you out. But the answer here is going to be C. Number 23, I'm going to handle this just like we did those other ones above. First, we'll reduce this fraction. 12 divided by 3 is going to be 4. And then we have x to the 6th over x squared. So we have x to the 4th. Okay. I guess I'll show how I got that. 6 minus 2 times y to the power of negative 4 minus negative 6, which would be negative 4 plus 6, times z to the power of 2 minus 3. So we have 4 times x to the 4th times y to the 2nd power times z to the negative 1st power. So if we want to rewrite that without any negative exponents, we're going to have to move this z down to the denominator. And we don't really need this raised to the 1 power, so we'll just delete that, and this is going to be our answer. And that's going to be choice D. Okay, we got one last little section here. Number 24, we're going to go ahead and first regroup this. Negative 3 times negative 7 times a to the 4th times a squared times b to the 8th times b to the 4th. Now I'm going to use the property, so I'm not going to completely expand this. I won't write this as like a times a times a times a. I'm just going to use the exponent properties to combine these. So negative 3 times negative 7 is going to be positive 21. And then when we multiply two powers with the same base, we add the exponents. Now we can go ahead and just add those exponents. So you get 21 times a to the 6th times b to the 12th. Number 25, got 36 over 24, which I can reduce. It reduces to 3 halves. And then we've got x to the 11th divided by x to the 5th. So it's going to be x to the 11th minus 5. Which will be 11 minus 5 here is going to be 6. So we can rewrite this as 3x to the 6th all divided by 2. Number 26, we've got negative 25 over 5 here. Okay, negative 25 divided by 5 is going to be negative 5. Then m to the 7th divided by m to the 1st would be m to the 7 minus 1. Then I have my n's, n to the power of 3 minus 6. Then I have my p's. P to the power of 4 minus negative 2, which would be equivalent to 4 plus 2. So here I have negative 5 times m to the 6th times m to the negative 3rd power times p to the 6th. I'm not supposed to have any negative exponents here, so I'm going to rewrite this, but with this n cubed in the denominator. Number 27 says 3x cubed times y squared times z, and all that's being raised to the 5th power. So what we want to do is actually raise each of those factors to the 5th power. Anytime you raise a power to a power, you do multiply those powers, which is going to give you a little clue on what's going to happen next. 3 to the 5th, I'm just going to leave it like that. You do have a calculator, so you could probably go ahead and evaluate that. But that's just a little bit too much for me to do in my head. So I think I'm just going to leave it like 3 to the 5th. And then we have x cubed to the 5th. 3 times 5 is 15. So we have x to the 15th power times y to the 10th power. 2 times 5 is 10. And then z to the 5th. Nothing to multiply there, so this is your answer. Number 28, we need to start by multiplying these factors in the denominator together. So I'll start it with that. So with my numerator, actually we've got two things happening here. With my numerator, I'm going to distribute that power of 2. Negative 5 squared is 25. And then negative 2 times 2 is negative 4, so that's a to the negative 4th power. 3 times 2 is 6, so we have b to the 6th power. All over. Now let's simplify that denominator. 5 times 3 is 15. 3 plus 1, I'm adding those exponents. 3 plus 1 is 4, so that's a to the 4th. And then negative 3 plus 1 is negative 2. So times b to the negative 2nd power. Now I'm ready to start simplifying this. 25 over 15 will reduce to 5/3. Then we have a to the negative 4th minus 4 times b to the 6th minus negative 2, or in other words, 6 plus 2. So here we've got 5/3 times a to the negative 8th times b to the positive 8th power. Now, I don't want any negative exponents in my final answer, so I'm going to move that a to the negative 8th to the denominator and change this exponent to be positive. And then b to the 8th will end up in the numerator. So here's your answer for number 28. Our last problem here, number 29. Now, anytime you raise something to the 0th power, it's going to equal 1. So this whole first expression is just 1. And then we have times 5 times x to the 0th, again that's just 1, times y to the 7th. And so we actually end up getting a pretty easy one here at the end. We just get y times y to the 7th. You do not have to write the times 1 because that is the identity element for multiplication. It doesn't do anything when you multiply by 1. So my final answer here is just that, 5 times y to the 7th. And that's it for tonight's homework. Thanks for watching, and y'all have a great day.